So this video will focus mainly on current electricity. We've moved past static electricity. Remember, static electricity is where we have charges that are either standing still or not moving very much. This is when we had our three methods of charging, and pretty much things stood where they were. Current electricity, on the other hand, is all about movement. So if you think current electricity, we're talking about moving. So our first concept is current. Current is just a flow of electric charge. It's the flow of electric charge. Most often this is associated with electrons. This is associated with electrons. The symbol that we use for current is I. And the unit is an ampere. That is a French word named after Mr. Ampere. More often we'll just call it an amp and abbreviated as an A. Now there's one idea associated with current that we should cover first. Current is the flow of electric charge. So if we draw a wire here, and it has electrons that are moving through the wire. So I'm going to do, remember, E with a minus sign is a negative charge, or an electron, and I'm just going to draw a few. So we have these electrons flowing through a wire. We're going to take what's called a cross-section. Now a cross-section is if we took a piece of wire and cut it at any point and then turned to face the cut end towards us, it would look like a circle. That's just a cross-section. We look at how much charge passes through this cross-section every second, and that gives us our current. There is a little bit of math that we can do with this. We won't do a whole bunch of the math associated with this simply because it's not a formula that they give you on your state reference table. But current, or I, can also be called coulombs, or charge, per second. It's the charge per second that crosses through that cross-sectional area. Okay, so example problem 1. We'll only do 2, so these are a quick 2. So the amount of charge that passes through a certain wire in 2 seconds is 1.67 coulombs. Determine the current. So we said up here that current is just coulombs per second. They gave us everything we needed. So I'm going to draw Q is our charge. It's pretty much just standard. It's 1.67 coulombs. T for time, once again a standard. That's 2.00 seconds. And if we're looking for current, I, we just want to divide charge over time. And plug in your numbers, 1.67 over 2. And we should get that I is about 0.835 amps. Okay. And so that's as simple as it gets for these problems. You will see a few of these on your WebAssign. So I just wanted you to have an example problem for that. The other type of problem you may see, and I know there's 1 or 2 on your WebAssign, is how many electrons are in 1.67 coulombs. So the reason I'm using 1.67 coulombs is because we used it up here in example 1. So I want to show you exactly how many electrons are associated with this current. Okay. So we have our charge, 1.67 coulombs, and we also have the charge of an electron. Now this is a number you don't have to memorize. This will be on your reference table, but it's 1.6 times 10 to the negative 19th coulombs. So how do we figure this out? Well, this might look like a pretty, I don't know, it might look like a hard problem. You know, electrons, coulombs, but you've seen these problems in math class all the time. If we have 100 Snickers bars to split between 5 people, how many Snickers bars does each person get? Well, all we have to do is divide. It's the same thing here. So we're going to get Q over QE minus. So the total charge divided by the charge in an electron. So 1.67 divided by 1.6 times 10 to the 19th. Now I'm going to add the units here. You don't have to add the units in your problems, but I'm going to put them here for emphasis. When you take a coulomb and divide it by a coulomb, what happens to the units? Well, they're going to cancel out. So our units cancel out and we're left with just a number. But that's okay, that's what we want. We want just a number. We want to know how many electrons there are. And so this comes out to be 1.04 times 10 to the 19th electrons. And that's a lot. So we have times a factor of 19 times 10 to the 19th electrons associated with a charge up here that's less than 1. We don't even have a full current. So this is a current less than 1. We don't even have a full amp, and we're already up to 1 times 10 to the 19th electrons. So there are a lot of electrons flowing here.